Okay, now we move to harmonic oscillator. Harmonic oscillator. Harmonic oscillator a particle moving under a potential barrier defined by Hooke's law is defined as harmonic oscillator. A body moving under simple harmonic motion can be represented by sine or cosine wave function with x is equal to r cos omega t and y is equal to, also we can write x is equal to r cos theta, where r is amplitude. And what is Hooke's law? Hooke's law is, according to Hooke's law, f is equal to minus kx. Okay, and we know v velocity is equal to dx divided by dt, and this will be equal to, when we take the derivative of r cos omega, it will be minus r omega sine omega t, and acceleration will be is equal to dv divided by dt, which is equal to minus r, it will be minus r omega square cos omega t, and this is equal to minus omega square and r cos omega t, which is equal to minus omega square and x. And you know f is equal to ma, and I am writing m, and a is minus omega square and x. The negative gradient, this negative gradient of the potential called force, f is equal to minus dv divided by dx. So what is f? It is minus m omega square x dv divided by dx. Now we will integrate it, and after integrating by separating the variables, okay, it is minus plus, so mv square into dv, it is from 0 to x, which is equal to mv square, and since it is x, it is also 0 to x dx. So v, and apply the limit, 0 to x is equal to 0 to x, mv square m omega square and this is x square by 2 from 0 to x. Upper limit minus lower limit, upper limit minus lower limit, it will be v minus 0 is equal to m omega square into x square by 2 minus 0, and this is v is equal to 1 by 2 m omega square, and this is x square. It's okay. So for harmonic oscillator, the potential energy function is given by potential energy. So suppose this is A. For harmonic oscillator, the potential energy function is given by A. This is potential energy, which can be written as also V of x. Okay. So for harmonic oscillator, the potential energy function is given by A, and kinetic energy is equal to 1 over 2 mv square, and this is equal to 1 over 2m m square v square m square and v square, which is equal to p square divided by 2m. Total energy of harmonic oscillator at any instant therefore is equal to total energy is equal to, which is equal to px square divided by 2m plus 1 by 2 m omega square and x square. The classical expression of total energy of harmonic oscillator is given by, yes, it is okay. The quantum mechanical operator of total energy of a system is known as Hamiltonian. The quantum mechanical operator of total energy E of a system is known as Hamiltonian, represented by H operator. Therefore, the quantum mechanical expression for energy of harmonic oscillator, it will be equal to H operator is equal to P x square operator divided by 2m plus 1 by 2 m omega square and x square. Okay. We define two-dimensional operators. Now we define two-dimensional operators, A operator dagger and A. How? For harmonic oscillator such that their commutator should be 1, means commutator of this and commutators of this should be equal to 1, okay. Where, yes, so what is the value of A and A dagger? It's these values are A is equal to 1 by 2 m omega h cot, okay, and minus iota px plus m omega x. This is the value of A, and the value of A dagger, it is equal to 1 over 2 m omega h cot minus iota px, okay, plus, yes, it is plus, this is plus, and in case of dagger this is minus, okay, plus m omega x. Okay, now we find this solution. We will prove that this is equal to 1. to prove that this is equal to 1, yes, we know we apply just like A dagger, dagger, and this is equal to just like it will be 1 over 2m omega h cut into iota px plus m omega x, 1 over 2m omega h cut and minus iota px plus m omega okay. Now we'll write it. So what is, we'll take this one, okay, it will be 1 over 2m omega h cut square, okay, and iota px plus m omega x minus iota px plus m okay. Now we will use relation by using a property. The property is a plus b and c plus d. This operator is equal to AC plus operator A and commutator operator A and D plus commutator of operator B and C plus commutator of B and D, okay. By using this property, this will be equal to, this equation will be written sin square, it will be 1 over 2m omega h cut and this will be equal to iota px and this one minus iota px, okay, its commutator plus iota px and m x plus m omega x and minus iota px plus m omega x m omega x and now it will be equal to 1 divided by h cut, and you know x and x operator, similar operator, are always 0. Yes, it will be minus iota square minus iota